or we will do our best to answer questions. This is a much more free-flowing session. So in other words, we're going to talk about cybersecurity, Data Mesh, and Delta Lake, obviously. But by the same token, we do want lots of questions. So please go ahead and chime in with your questions. And for starters, why don't you go ahead and tell us right now, like, where are you based out of? In my case, I am based out of the Kirkland, Washington, i.e. Seattle area. And my guest happens to be also
just south of you in Bellevue area, Newcastle for anyone in the local area.
Yes, in fact, actually, what was really funny was that Ryan and I actually both. I used to be his neighbor, and then in Newcastle, and just never do that, which is pretty brutal. So, but it is what it is. So we're on live on YouTube, which is great. So now we're just seeing if we're live on. Oh, looks like we are actually live on LinkedIn, which is great as well. So perfect. Let's go ahead and start the show. So again, to everybody that is wondering what's going on, my name is Denny Lee. You are attending the first of a monthly series called D3L2, or Delta Lake Discussions with Denny Lee. I'm here with my first guest, which is Ryan Harris, and you are attending the session Cybersecurity, Data Mesh, and Delta Lake at HSBC. I'm going to start sharing because the focus will just be mostly on conversations between myself and Ryan. So let me stop sharing, number one. And number two, Ryan, why don't you introduce yourself a little bit?
Hey, I'm Ryan Harris, a principal cybersecurity engineer here at HSBC. I've been doing cyber stuff for about 25 years now. Got into data about 10 years ago, and cybersecurity has lots of data. So data analytics and large data analytics have been really critical to doing the cybersecurity mission.
Cool. Okay. And so that always glad to be chatting with you. Just to provide a little additional context, Ryan and I have known each other for quite some time. In fact, we both used to run the Seattle Spark and AI meetup when it was still called Seattle Spark Meetup. In fact, so that's sort of aging us or defining our age here a little bit too much. So we've been working on Spark for quite some time. Let's see. One of the things I wanted to start. Oh, right. Some quick logistics again. If you have any questions on what we talk about, whether you're coming in from LinkedIn, from YouTube, or from Zoom, the Linux Foundation Zoom, by all means, just chime in and we'll do our best to answer your questions. But let's dive into some of the details first. So actually, before we even dive into those details, Ryan, why don't you tell a little bit about your background and how you even got into cybersecurity in the first place? And for that matter, cybersecurity at HSBC, because it's very specific when it comes to banking systems.
Yeah, from the early days of the internet and computing, I was always kind of interested in the hacking scene and how people broke into things and how you subvert security. And in the early days, things were really quite terrible, and it was really easy to do. And I started my career in the Air Force, got kind of my background there right out of college. And after that, I'd been working in kind of highly regulated government environment, and that was one of the places that cared about cybersecurity. And when I got out, really banks were one of the only other people that actually cared about cyber. And I got involved with Zions Bank down in Utah. And this is like before the first phishing attacks were even a thing. We got to experience like phishing when it first got started and how to defend against that. But at Zions, I worked as a penetration tester, so breaking into applications and bank systems and learning how to harden those. And as these phishing attacks started rolling out and other sorts of threats, we started looking at our log data, and were able to realize that we could identify customers that had visited a phishing website, even if they hadn't logged in to banking in that session through cookies and stuff like that, tying them to their refer logs, but that we could then reach out to customers and say, hey, did you go to this kind of strange email site that you, and oh yeah, we did. Okay, you shouldn't have. Let's change your password, change all this kind of stuff. and also working in credit card skimming and other sorts of activities like that to identify compromised ATMs and things of that nature. So got involved with doing kind of data analytics and working on log streams of data at Zions, and spent almost 15 years doing that, and was then kind of looking for the next place, the next step, and was considering getting out of banking because banking's hard and it's old and it's kind of crusty, but that's where the problems are and that's where the threat is, and it's what I knew. So took it to the next level, came to HSBC, same problems, larger scale.
So that's pretty amazing. So when you say same problems, larger scale, can you give us some context behind like exactly how much, like the number of customers or how much assets are impacted or the amount of data? I'm just curious, like, that's got to be huge, right? So.
Yeah, I mean, Zions was a Western regional bank, and they had different rules based on what state they were located in. HSBC, global bank, different rules depending on which country you're operating in. So instead of dealing with 10,000 people employee wise or whatever, we've got 250,000. So the data sources that I worked at Zions were in the large number of terabytes. Now I've got stuff that are over petabytes. But that's what's nice about solving these problems in a kind of big data scalable way, is once you have a solution to the problem, it doesn't really matter how big it is. You just cost a little more for your compute, throw more nodes at it, and if you're solving the problem efficiently, it scales.
Got it. Okay, so that's really interesting. And so, if I recall correctly from your one of your previous data and AI sessions, it was basically you're talking about like 100 to 200 terabytes of data a day that you're actually processing.
Yeah. Well, I would say we're probably processing at this point 50 to 75 terabytes of that. That total was the kind of total stream of exhaust data that we assume to be getting generated, and it is our mission to try to capture all of it and do analytics on it. But we're working towards that goal.
Got it. And then I'm just curious, what are some of the data sources you're typically utilizing for something like this? I mean, it seems massive, and I love the idea, and we'll definitely dive into this a little shortly, which is like, I love the idea that you're like, hell yeah, we just toss a node into it and you can solve the problem. But by the same token, I'm just curious, like, what type of data sources you're using? How dirty is that data? I'm just curious.
All different types of sources, firewall data, proxy log data, NetFlow logs, antivirus logs, endpoint defense logs from agents on the systems. So all of these various assets, like over 1 million assets, VMs, laptops, servers, mobile phones, ATMs, things like that, things that connect and communicate on the bank network. We track all of those individually, track what security controls are applied to them, and get the logs that would produce artifacts from any of their activity, and then correlate those feeds together. So some of them are really straightforward. NetFlow, it's like 10 fields, source, destination, number of packets, stuff like that. Other ones, like the endpoint defense logs, those have 250 plus different sub event types that are all JSON schemas that change at a whim, and make it far more complicated to dynamically process that sort of data, always changing on you. So the pipeline has to be built to accommodate that reality.
Okay, I'll table that discussion right now about in terms of like the changing schemas and things, but I did want to basically shift the conversation to the first part of it, which is a little bit more about cybersecurity itself. Like, what are, and I guess you sort of implied some of, not implied, mentioned some of it already, which is what are some of the key challenges that you face that in cybersecurity that may be unique, or maybe even for that matter, in some cases may be similar to what other data processing systems or data challenges typically are?
In cybersecurity systems generate lots of data. I mean, if you think about if you're just going to browse a web page, you're hitting dozens of links in that one web page. Each of those links is generating an artifact, spinning up the web browser, is starting a process. There's network traffic that's going on, any artifacts that are getting downloaded or getting scanned by AV. And all of these actions are generating unique log events. So I process probably 5 to 10 billion events in a given day across all of our systems. And most of those events are not directly actionable, or you're not searching on those, but they provide the context to detections that you may be looking for. So you're looking for this needle in a haystack, and when you find that needle, you need to add contextual data and forward that on to the analyst to try to determine whether or not that's something that needs to be further investigated.
Gotcha. And then I guess one of the things that you noted before is that in addition to all the data processing issues, there seems to be like this lack of documentation and data dictionaries, and you typically had like these bespoke vendor data silos that you're typically working with. And I'm just curious, can you describe that a little bit? Because I think this will segue quite nicely into the conversations about data mesh.
Yeah, the individual vendors will have data that's relevant to their application or system that they'll store in some way that met their goals. Maybe it's a microservices API to hit and get the data out of. Maybe it's a backend database that's got a relational structure to it. They don't always tell you all of the tables that they're using that they built their application around, but that's a database that now exists in your environment that has the relevant data to your kind of cyber mission that you're trying to get. So you sometimes get into these reverse engineering of vendor data sources, or sometimes the API will just barf all of its results back in like a single line JSON array that's got hundreds of gigabytes of data in it. That doesn't easily parse out so well. So you need to pre-process those sorts of things. The vendors didn't think about how data from AV may relate to the proxy data. They do relate, but they didn't help to map out how you should relationally join that data to provide the context of what you're actually looking for.
Right. And so then, okay, well then, so then how do you, with this, especially with all of this data flowing in which it seems like the schemas can change, the inferences, what they mean can change, yet you need to have a business standard to work off of, right? So that way you can do your actual analytics. How do you actually get all these systems to actually work together?
Mostly by following the bronze, silver, gold approach to delta table curation, where we have the raw data that's coming in its native format, and then our goal is to create initially silver tables for all of those data sources that represent in a delta table, nicely structured by the relevant fields, column statistics collected, partitioned appropriately, but that contain all of the data in those sources. That's not necessarily how you want to use it for that use case, but then building curated gold views and materialized tables from those silver tables that can be linked together to either display the metrics, dashboards, things like that we're trying to display, that we know that story we're trying to tell, or that can help join disparate sources of data together. And then sometimes the threat hunters or other data analysts are just jumping into those silver tables and doing ad hoc analysis on them to figure out what sort of automated analysis we need to be doing on a continual basis to find the things that they identify through that ad hoc analytics.
Okay, perfect. So let's break it down a little bit. So let's start actually with the data processing in the Medallion architecture, as you say. So just to provide context to everybody, that's attending right now, that if you by any chance haven't heard the umpteenth time of the various Delta Lake conversations we've had, right? The context is basically it's a data quality framework when we talk about that medallion architecture to go from the bronze, which the data is just basically being written to disk as fast as you possibly can. So that way you can keep state, to silver, just what Ryan had mentioned, which is allows us to actually be able to have some way for us to join and parse and join these disparate systems together. And gold is when you basically said, okay, now that I've done that joining, I can go ahead and run, whether I'm running my analytics or machine learning or AI or data science or whatever else, I can go ahead and do those things against those data sets. So let's start with the bronze section first, though, which is basically, again, you had noted that you've got all of these different sources, which may have different schemas, may change over time. If from your perspective, when you're taking, for example, that one example where you had where the REST API was barfing out like a single array, right? Something like this. Is do you then in this case, and by the way, there's no right or wrong answer to anybody that's listening to this conversation. Everybody has different approaches to this. I'm just curious, do you take, for example, that one, do you just write it as is, or do you try to parse that data in the bronze table, or do you basically just allow the barf to happen per se? It gets written to storage, and then basically have a specific pipeline that allows you to process that.
So our raw data lake is kind of outside that medallion architecture, where we capture the complete raw data in whatever form we had, and that means that if we ever find that we messed up somehow in how we were processing it, or made any mistakes, or have questions about why did that processing fail, we can go back to the original source that we captured and say, this is what it is. And then as we're going into that medallion architecture, typically the bronze table is more of a view or disposable. We don't maintain that bronze table as it gets loaded to silver. The exception would be in those cases like the one that barfs out a single string of JSON that needs to be pre-processed. That pre-processing will land in kind of a persistent bronze table that we keep around just in case we need to backload it, because it's so much, like, storage is cheap. So to avoid having to do that pre-processing again, just to be able to load it, we keep that. But in cases where our source is reasonably sized, gzip compressed JSON or Avro files or things like that, we just leave that in raw, and the bronze is kind of ephemeral.
Got it. And so from your perspective, like, are there typically different teams that are accessing these different data sources, or which is basically where the siloed is coming from, or is the silo coming from other aspects? Because that's just one example of you taking that. I love the fact that we're now officially calling REST APIs barfing things out, but REST APIs barfing its data out. The context is like how. I guess what I'm leading on to is more like this context into why is this a mesh per se?
So we have different customers that are cybersecurity customers that are building different use cases around the data. One team is focused on cybersecurity metrics dashboarding, reporting kind of the status of all of these security controls. And these are dashboards that are viewed on a daily basis by regional CISOs and other executive management, just to know the coverage, or if a system is down and like, hey, antivirus isn't being updated here, what's the status of control X? So that's kind of one use case. There's other use cases where threat hunters are involved in the data. Now, the threat hunters care about some of the same data sets that the cybersecurity metrics cares about, but metrics team is looking for a much more curated, defined view of that data, whereas the threat hunters just want the raw data. They want everything. If there's anomalies in the data, those anomalies might be interesting. So don't cleanse any of that sort of stuff out. So some data sources, maybe initially one team wants, but almost any data source that we have, there are use cases from other teams. And that's why the data mesh aspect is when somebody requests the raw data, we onboard that as soon as possible, and we make that raw data available to those individual teams to process themselves if they want to start jumping in, get using it. But at the same time, in parallel, we have a core team that's also looking to do this core processing of all of those raw sources into a common data lake environment that everybody can access. And now if somebody else wants to see the proxy log data, they don't need to figure out how to process that syslog stream of gzip files, whatever. All of that data exists in the both the curated view that metrics may be using, as well as that silver enriched table that has all of the data. And then if they decide, well, I need a view that's more like this for my use case, we'll create another view, maybe materialize it depending on their needs, and have multiple views that stack on that enriched table. And then we can have a lineage that tracks from the view going back to the source data, going all the way back to those original files that we ingested, and can ensure that we've ingested all of the data. And if there were any gaps or issues during data ingestion, that those are accounted for in our data lineage.
Right. So then I guess there's an implication. So when you build up these data mesh environments, right? Because, for example, centralized platforms, typically we could say, hey, there's one group, that core team, that ensures all the data is exactly the way it is, but of course it's extremely slow, right? Or what you had been fighting, which is basically everybody was siloed off together, so they did their own thing, but then they're not doing some shared version of a data dictionary, shared definition. So all of a sudden, metric X between the threat hunters versus the metrics dashboard all of a sudden mean different things, because they literally use the same terminology, excuse me, but they actually use the different definition of said terminology. So, but then if you have a data mesh, does that imply there's that aspect of a centralized system where you're going to have all have the same data dictionaries? Is there like a metadata, master data management of some type, or data dictionary of some type that you use in order to ensure that all the different teams are actually able to have the whatever terminology they use, they actually have the same definitions?
Yeah, I mean, part of that I think goes to how you choose to implement a data mesh within a given environment. And, typically with a data mesh, the team that is generating a data source is the one that's supposed to be responsible for that documentation and lineage and maintenance of that. Now, most teams don't really want to do that sort of thing. So you'll kind of find this kind of ad hoc evolution of data where people will first throw stuff together, and we have a collaboration zone where they can share off their kind of work product with other teams within the environment. But it's obvious that this is a data source that's being generated by Team X. And Team X may have put together other data sources that exist in the enriched lake, combined them, joined them in a certain way, filtered them. Technically, if they are going to be the ones maintaining that authoritative source going forward, they should be the ones that are responsible for all that, responsible for the maintenance and data quality of that. But typically those teams don't want that responsibility, and that initiates the conversation of how do we migrate what we've built here into something that's centrally managed that you all will take care of, and we'll just come to you when we need to make changes to it. And that's kind of the software development CI/CD maturity model.
No, it makes a lot of sense. I mean, and I guess what you're implying is that it's really different for different teams, right? Even within the same organization, right? Some of them are going to follow almost like the traditional REST API. I control everything. I will give you the document, the definitions. You're good to go. And some teams will be more like, okay, we just did this temporarily. We're done. We can advocate for why this is applicable for everybody. So that's why the central core team needs to take it over, and then the central core team takes it over, things of that nature. I guess there's a lot of horse trading, I guess, in these type of scenarios.
Yeah, and a lot of data, I mean, it really depends on how data mesh exists within an organization. Some teams may be really a microservices type architecture where they're managing a thing that produces data. And in that case, it really should be that team that is managing it. But in our case, most of the results of data, the data products that are produced are the results of combining data from upstream systems that typically aren't owned by any internal team. They come from external vendor systems. And who really owns that? That's where the central team comes in as the kind of owner of last resort.
No, that makes sense. And by the way, so we're starting to get some questions in, so we're going to start chiming into some of them. But one little cool comment is that it's a bit of a tangent, but somebody wanted to call out that that your hairstyle is really cool. So just want to add that right from the starters. So, all right, Dilip, I'm hopefully I'm saying your name correctly, so I apologize if I'm not. Since it has this great question from the Linux Foundation Zoom link here. And like I said before, we've got questions from LinkedIn and also from YouTube, just for everybody that you're more than welcome to chime in. The question here is, since HSBC is a global bank, do you have separate common or raw data lakes per region to adhere to regional compliance requirements?
Yes, we it depends on the data visa policy and what data we're allowed to host in a given region. But certain highly restricted countries, their data has to be kept in country, and we have to have deployments that are targeted for those environments based on the data restrictions.
Gotcha. And then another question, this is anonymous here, but how many data analysts and engineers do you maintain these data pipelines and tables and visualizations and dashboards that you have? Like how big's your team basically?
Um, it's it kind of depends. We have roughly a team of 5 to 10 people that are focused on the data acquisition, getting the raw data from all of these internal, external sources, landing it into the raw lake. We have another core team of 5 to 10 data engineers that are producing all of that data into these common Delta tables. But then there's additional data engineers and analysts that are distributed into all of these teams. And, you know, as an ML engineer, a data engineer, it's that kind of fuzzy ground of what sort of work you do. The data mesh tries to democratize data analysis. So everybody's a data engineer to a certain degree, but we do have these core roles that are focused exclusively on managing the core stuff in a centralized way.
No, it makes a lot of sense. Cool. And so, all right, going back to earlier, you had mentioned that basically with all the data that you're processing, all you had to do is just add another node and you can automatically solve that particular problem. I'm just curious, is in the end, is it just because everybody in HSBC, or like, did you have a problem convincing people to switch over to Spark in order to be able to do that? And apologize for folks that might not already know. We've Ryan and myself have had previous conversations about this, so that's why I'm just jumping directly to the part that says, yeah, we're using Spark. So I'm just curious, like, what were some of the problems that you faced, and then this invariably will lead to also like, why did you also utilize Delta Lake, by the way? But let's start with the Spark aspect first here.
Yeah, so like one of our data sources, the endpoint defense logs, that's about 3 to 4 terabytes of compressed data a day. Uncompressed, that's about 30 to 40 terabytes. And it was such a large stream that nobody was getting it and processing it before we started. The data is available through a vendor portal. There was ways to search that data, so it's not like we were completely blind to it, but we weren't maintaining our own history. We couldn't go back years into that data and do searches previously. Now, my background in working with Hadoop and other big data processing, I knew that I could process that at scale with cloud resources. I just needed enough to do it, and Spark was the next step. Now, initially when I was processing that, it was throw a bunch of nodes at it and get it done. But as I was looking at that processing, I knew that it was too much compute for really what was needed, and that there were ways of optimizing it. So that entered the next phase of like, great, I can throw more nodes at this to solve the problem, but now how do I make this more efficient? And that was a significant challenge, but now it's more efficient, and we can still throw more nodes at it if we need to. We just have to start with far fewer nodes.
Gotcha. And then so this allowed you to basically handle the scale, and you're becoming more efficient, so it doesn't cost you as much money, which is always a good thing. But then there's a great question actually from Predula, and I again apologize if I'm not saying your name correctly. Like, what do you do? Like, what, for example? Okay, I'm going to ask it slightly differently than the question that was asked, which is like, why using delta tables? Is it because all of the data requires ACID transactions that you have, or are there, like, what's the context behind it, I guess, when you're processing all this cybersecurity data?
So what makes delta tables great for us is that they are a streaming source and sink for these data pipelines. So when we were initially building a lot of our data pipelines, we were using a batch-based approach. It's very common, it's what people understand, and it was easy to implement. A lot of our data sources were coming in an hourly, daily basis, and even these endpoint defense logs that are flowing in every 5 minutes, we just said, look, we're going to start by processing these once a day and then move to kind of an hourly basis. But by building things with delta tables and migrating all of our pipelines to streaming that we just run on a daily basis or an hourly basis or a continuous basis for the stuff that's arriving every 5 minutes, it means we can have one common type of ETL approach that works regardless of how frequently we need to load the data. And then we don't need to come up with, well, this data comes in daily, so we're going to do it this way. Oh, but now they decided to start getting it hourly. We need to change our approach. It's just one common method.
So then, by that very definition, that in essence, all your data requires, in essence, that ACID transactions, because of the fact that it doesn't matter. Like, basically, the problem of streaming versus batch purely is a latency problem, not a business logic problem then.
Correct. And I would say that a lot of the data that we're doing doesn't necessarily require the full ACID compliance. We're not making those sorts of updates in place to tables and stuff like that. We're mostly pulling snapshots of other data and joining those together. But Delta also makes it very convenient when you're landing a new snapshot of the data, but you already have an existing reporting query that's running on what was the current snapshot of the data. That query still just finishes, and you don't worry about stepping on stuff, whether you're doing maintenance and optimizing tables or just doing updates to them.
No, got it. That makes a lot of sense. And so then, okay, there's actually a great question from Zachary, which is based, then how do you handle the data cataloging or data discovery of all of these different Delta Lake tables then? Like, especially in the large common area per se.
So our initial direction, we were looking at Azure Purview for our data catalog, but with the announcement last year of Unity Catalog and Databricks' direction with that, that is our new target that we are looking towards. Currently, we just organize the data in a structured way in our common data lake that people can map, because each individual landing zone in the data mesh has its own Databricks workspace. So within each of those workspaces currently, they're mapping the views and tables within the workspace to what they need for their day-to-day operations, which creates a little bit of overhead management for, as we add new tables into this central lake, how do you get those exposed? But it's in Azure Data Lake. People know where to go to browse and follow a common structure, and then the Delta table itself has its metadata around it. So it's fairly easy to find, but not what we're really looking for, which is that Unity catalog experience.
Got it. Thanks a lot, Ryan. And just for everybody's context, by the way, there's lots of different aspects when it comes to like obviously in this particular case, Ryan HBC, they're a Databricks customer, but the fact is that you can definitely do these same approaches when it comes to open source. And so we're always advocating for that aspect of the side of things. And so there, for example, there's a project called Data Hub that actually will allow you to go ahead and place the metadata into its set of stores so you can track it. Obviously, working with an HMS system allows you to track all these different tables, and so you put comments or extra descriptions to provide access to that. So there are definitely different approaches. The reality is most of these systems have their pros and cons, and so just exactly as Ryan described in his situation, and so. I don't think anybody's figured out the cleanest way yet, at least yet. I'm sure as time progresses, whether it's Databricks with Unity Catalog or Azure with Azure Purview or um, Lake Formation with AWS or whatever else that you're possibly using there, and Glue, excuse me, there'll be things will get better on this front, but it's still a bit of a progress, to put it lightly. So
now Purview is based on Apache Atlas, and before the Unity announcement, we were looking at hooks at how we could get Spark and Databricks to basically announce and message into Atlas these sorts of changes. We saw a development path for making that a reality, but with the announcement of Unity, we decided to let the Databricks engineers focus on that, and we would focus on other priorities.
yeah, it's that delicate balance of just trying to figure out which things do you want to tackle yourselves and which things you want to just we'll just let the vendor tackle it. So cool. I actually had one other question, but actually that's more directed to me. So I'm just going to answer that. And this is just going to give an opportunity. If anybody else has any questions, by all means, please chime in. There was a question from LinkedIn or from Deepanjan. And again, I apologize if I'm not saying your name correctly. What are the best ways or practices for an API to access Delta Lake? And that's the question. The context is assuming an external application wants to access the Delta table, what would some of those options be? And so long story short, it depends on what type of system you want to get access to it. So for example, if you're talking about a distributed system like Spark, well, you can always have Spark or Trino or PrestoDB or Flink. These systems can actually access your Delta tables directly, right? And that's not a big deal at all. By the same token, if you wanted more from an REST API style perspective, the most common approaches right now is to use the Delta Rust API. It also has Python binding, so you can actually use that, or using the Delta standalone from the Delta connectors or Delta standalone project that's in the connectors repo. It's designed for Scala and Java. So just as an FYI, so you can always access your Delta tables that way as well. So again, multiple distributed systems that can access it, and also multiple languages that can access it. So you're sort of your call on which one you want to go do. And so saying that, we're actually almost near the time up. So I'm going to go ahead and go through a couple more questions. But before we go through those questions, Ryan, I just want to ask, is there anything else you think you want to add from the standpoint of like best practices around of data mesh and data lakes per se, and Delta Lake per se?
I guess one thing I want to mention real quick on their connectors, Power BI, we're connecting directly to that from the Delta.io connectors page. So, yep, it depends on what your needs are, but there's lots of good resources from that connectors page. But as far as best practices with Delta Lake, Data Mesh, I would say that the Lakehouse architecture is not all that necessarily different from data mesh, and it's kind of a fuzzy line between where you want to draw. Our initial architecture was a distributed lakehouse architecture before data mesh was the hotness or that we even knew the term. So if you're implementing a data mesh, really think about how it fits your organization and the way you all work, and that there is no this is the way to do a data mesh, but the data mesh should benefit your work environment and the way your teams need to interact. And I think the way you design that mesh and the way you define the interactions between teams really depends on how much centralized control you want over that, and just kind of where you want to place that needle.
Awesome. Okay, actually, tons of questions are coming in, so let's try to see how many of these we can actually help answer. One question which I did want to get in front of, Samita, you asked a question comparing Delta Lake versus Apps Synapse Analytics. One of the things we don't do in their sessions, we don't do comparisons, compete scenarios, mainly because it does require us to dive much deeper into each situation, and I can honestly say none of us are probably ASA experts, and so we want to be fair to any of the potentially competing projects. So understand you're interested, but you might want to chime in on, for example, you could always go into the Delta Lake user Slack, or which is go.delta.io/Slack. You can ask the questions there, where people will be provide a lot more context. So apologies for not being able to try to answer that question right away. And so Tarachit asked a cool question. What are the potential risks of pursuing this data mesh architecture from your perspective, since you've built this, and just like you said, all the hotness about before even the terminology itself, but what were the risks, for doing such things?
I think you do have the risk that individual teams, everybody wants to just get the data, self-service it themselves, and you'll end up with different teams that are processing the same data in sometimes dissimilar ways. Sometimes they're processing it the same way, just on different schedules, or there's all of these kind of edge cases where people may not be talking off the same sheet of music. That can all be mitigated through communication and central controls if needed. But with the data mesh, depending on how independent and self-service you're doing it, communication is definitely a key. In some places where we've let people do their own kind of infrastructure on a self-service basis, writing their own Terraform, their Terraform didn't necessarily follow the core Terraform that we were writing. So then when we inherited the maintenance of that project, it meant we had tech debt that we had to refactor to kind of bring that mesh node into compliance with how we were doing things. But at the same time, it allowed that node of the mesh to move quickly and independent of the time restrictions and availability of the central team. So that's that balance of moving fast versus accruing tech debt.
Makes a lot of sense. Okay, we've got time for only 2 more questions. I'll answer one of them, and then we'll have you answer the other one, okay? So the question is, can we have a millisecond latency to get our data for UI purposes from Delta Lake? The quick answer is that Delta Lake is designed more for OLAP purposes, online analytical processing. So typically you're doing a batch process. So because of that, typically it's not millisecond latency. Now, if you're talking about like getting the data directly from for example, Spark structured streaming, yes, that's completely designed for that type of purpose. But from the standpoint, especially with Project Lightspeed coming in, but from the standpoint of getting directly from the table, typically we're talking in not the millisecond area, we're talking in the second area, like in terms of being able to get an aggregate of that. Okay, so just wanted to give you some context, Pradula. And then the final question, again, I apologize for not answering all the questions, but we have time for the last one here. If you already have a lakehouse, and this is specific to data mesh and financials, okay? So this is to you, Ryan. If you already have a lakehouse that's already using a Medallion architecture for your financial services company, so very applicable, what is the shift to data mesh, or what is the difficulty to convert to a mesh?
It's not really that difficult at all. In our case, the main difference between a unified shared environment with kind of one data lake and one Databricks workspace is just that each node of the mesh ends up with its own Databricks workspace and its own Azure Data Lake service that they can maintain their own kind of private lake house within that mesh node if they want. So the mesh node becomes either a subscription in Azure or a resource group. It's just an isolated pocket of resources that are controlled exclusively by the needs of that participant of the mesh. So if you had a centralized environment, you could kind of turn that into a mesh just by saying, okay, this one central one is the core platform, and now we're forking off another zone that's using that, but doing its own thing independently.
Perfect, Ryan. Thank you very much. This has been an awesome session. I already chimed in. If you have more questions, please join us at go.delta.io/Slack. You can ask us questions there. We apologize for not answering all of the questions, but again, you can just chime us there. So Ryan, again, thank you very much for spending your time with us today and answering, providing context around cybersecurity, data mesh, and Delta Lake, and answering all these wonderful questions.
Thanks, Denny. It's a lot of fun.
Awesome. Thank you very much. Paige, Marissa, I think we're good to go. So anything else we need to